Hello class, so for this video, we'll be studying chapter 7, which is differential amplifiers. So let us first define what differential amplifiers are. So the differential amplifier circuit is an extremely popular connection used in IC circuit. So itong differential amplifiers class, ito ay yung mga laman kumbaga ng mga integrated circuits natin. So because of the function or the functionality rather ng differential amplifier, so this is very popular in IC connections. So the connection is described by considering the basic differential amplifier here. Itong figure na to. So notice that the circuit has two separate inputs. Yung inputs natin dito, that is itong VI1 na to, and then VI2, and two separate outputs, that VO1 and VO2. And the emitters are connected together. So these are our emitters, they are connected to each other. Whereas many differential amplifiers use two separate voltage supplies, the circuit can also operate using a single supply. So this circuit class, this can operate na isa lang yung lalagyan natin ng input signal, and then yung other sign is i-ground lang natin siya. So we have different modes of operation for differential amplifiers. So if gagawin natin siya na op-amp or a single IC, a single circuit, ito yung itsura niya. A single block, may dalawa tayong input, tapos may dalawa tayong output on this side. So pwede siya na ganun. Yan. Wala yung mic ko. Ayan. Okay. So a number of input signal combinations are possible. So ito yung mga combination ng natin. Combination na pwede natin gawin. So if an input signal is applied to either input with the other input connected to the ground, that is what we call a single-ended operation. So remember, in single-ended operation, kailangan ilalagay natin sa ground yung other side. If two opposite polarity input signals are applied, the operation is referred to as double-ended. So take note, dapat yung signal na ipapasok natin ay opposite yung polarity nilang dalawa. Now, if the same input is applied to the same input, same direction, same polarity is applied to both inputs, yun naman yung tinatawag natin na common mode operation. So, meron tayong tatlong mode of operation. That is single-ended operation, double-ended operation, and common mode operation. So, in single-ended operation, a single input signal is applied. However, due to common emitter connection, the input signal operates both transistors, resulting in output from both collectors. So, as you can see in this circuit, ang mangyayari in single-ended operation, mag-ground tong part na to. Now, pag nag-ground yung part na yan, there will still be output dito sa kabilang sa kabilang collector natin. And the reason is, these two transistors are identical to each other. So, ibig sabihin, mag-work pa rin yung transistor na to on the other side with the same na parameters kung ano yung nag-work on the other side. In double-ended operation, two input signals are applied, and the difference of the inputs resulting in outputs from both collectors due to the difference of the signals applied to both inputs. So basically, sa double-ended operation, yung difference ng inputs natin, yun yung resulting output natin. So ang makukuha mo sa collector mo ay yung difference ng dalawang signal, opposite signal na ipapasok natin. Now, yung common mode operation naman, the common mode input signal, kaya nga common mode kasi common yung input signal to both differential inputs natin. Now, ang resulta nito are opposite signals at each collector. So, these signals are canceling or going to cancel each other. So, the resulting output signal is 0. Well, technically, syempre hindi exactly 0, but mababang-mababa yung nagiging result nito. So, as a practical matter, the opposite signals don't completely cancel and a small signal results. So, now, bakit ba ideal tong common mode operation natin? Or bakit ideal na kapag may common mode operation tayo, ay naging zero yung ano natin, effect niya dun sa circuit. Now, bakit nga ba ganun? Kasi itong common mode operation natin or common mode signals natin, these are usually in the presence, pumapasok to sa circuit natin in a form of noise. So kung noise yan, syempre hindi naman yan papasok sa isang input lang, di ba? Papasok yan sa both inputs natin. So kung ganun yung case, papasok siya sa lahat ng inputs natin, then gusto natin siyang matanggal or ma-cancel out yung effect niya doon sa circuit. Kasi nga noise siya, di ba? Unwanted siya. So with the common mode operation, naka-cancel sila. So later on, makikita natin kung bakit nga ba siya naka-cancel. But that is the advantage of using differential amplifiers. Because kung ano yung pumasok, kung if same na signal yung papasok on both on both inputs, ang tendency is i-cancel out nila yung each other pagdating sa output stage. So the main feature of a differential amplifier is the very large gain when opposite signals are applied to the inputs as compared to the very small gain resulting from common inputs. So the ratio of the difference gain to the common gain is called the common mode rejection ratio. So gusto natin, yung common mode rejection ratio natin is mataas kasi ibig sabihin, the higher the common mode rejection ratio or tinatawag din natin na CMRR, mas mataas yun, then ibig sabihin, mas mataas din yung capacity ng circuit mo or yung differential circuit mo to oppose common signals, which most of the time, they are noise nga. Yan. So, DC bias muna tayo of differential amplifier. So, for this one, we will still, same na, pag-analyze, katulad ng ginagawa natin dati. Now, let us first consider the DC bias. With AC inputs obtained from voltage sources, the DC voltage at each input is essentially connected to 0 volts. So, di ba kapag ka DC ang pinag-usapan, yung mga voltage source, yung mga AC sources natin or AC inputs, gagawin nating ground or 0. So, ito na yon. With each base voltage at 0 volts, the common emitter DC bias voltage is, since kinonect natin to sa ground, and kapag kinonect natin yan sa ground, tapos maglagay tayo dito ng node, let's say that is yung VB mo, then kitang-kita natin na kapag nag-KVL ka dito, you will have VB is equal to 0. Now, if VB is equal to 0 volts, then we can get VE. Because VBE, alam natin that this is 0.7. And VE is equal to VB minus VBE. Na nakuha natin sa double notation equation na VBE is equal to VB minus VE. So, doon natin siya nakuha. Yan. So, wala tayong problema doon. Ayan. Now, nakuha na natin yung VBE. Let us now determine the emitter DC bias current in the circuit. So, ang IE natin is, kung titingnan, before pala ako mag-begin with this analysis, take note muna yung mga nilagay nating currents, kumbaga. In this one, andito yung RE natin. So, take note, pinangalanan natin na IE is yung current at RE. So, take note of that. Tapos, yung current natin at IC ay yung pinangalanan natin IE over 2. Well, actually, IC yung pinangalan natin sa kanya. But, if you can see at the circuit, yung IC na to, tsaka yung IC na to, magko-combine sila at this point. Diba? So, pag nag-combine sila at this point, then, we can say na that is equal to IE. So, therefore, yung IC natin is equal to half ng IE tsaka half ng IE dito. Now, ang tanong, sir, bakit po equal yung IEs yung IC natin, yung dalawang IC natin dito? They will be equal because these transistors are similar. So, kung similar yung transistor na yan, ibig sabihin, parehas ng, di ba meron tayong characteristic curve ng IB versus our output voltage or IB versus VBE. or IB versus VCE. And kung same ang device, that same din yung characteristic nila. So kung same yung voltage drops doon kumbaga same yung voltage biases ng ating transistor, the same din yung mga currents doon sa kanila. So that is why similar sila. Kahit na grounded yung isang part, may input yung isang part, yung DC bias current natin dito ay hati lagi or divided by 2 at yun yung mapupunta dun sa dalawang IC natin. Now, assuming na yung IB natin is very, very small, so approximately, our IE over 2, yun na yung IC natin. So, ang approximation nga natin dito, IB is just very, very small. So, if that is the case, then we can do a loop na. So, yung loop natin is pwedeng manggaling from this point, dadaan ng VBE, pababa, palabas ng VEE. So, that is our loop. So, kung magki-KVL tayo doon, we will have IE is equal to, actually, gawin ko muna yung actual. Yung actual is VBE. This is NPN. No? This is NPN. Tapos plus to, minus plus lalabas. So, ang loop natin dito is negative VBE plus IERE plus VEE. Now, if we simplify natin yon, we will have VBE minus VEE minus negative VEE over RE, which is VEE minus 0.7 volts over RE. Now, this is our IE. Next, the emitter DC bias current is also called the tail current. So, itong IE na to, the current flowing at this RE, tinatawag din natin siya as tail current. So, assuming that the transistors are well matched, ito na nga yung sinabi ko kanina, that our ICs are the same. So, since same yung IC natin, we can just divide IE into 2 kasi same nga din sila ng value. So, therefore, yung collector voltage natin, that is the voltage at this point, we can get this by looping. So, take note, collector DC itong pinag-uusapan natin ha. The DC voltage at this point, pwede tayong mag-loop from this point. VCC, punta ng RC, punta ng VC. So, yung loop natin dito will be VCC plus minus ICRC, wherein IC is IE over 2, palabas plus VC1. So, if that is the case, also, pansinin natin, similar din yung ano natin. Since similar yung currents natin, similar yung values ng RC, we will have the same VC on both sides. So, we will have VC1 is equal to VC2, and it is equal to VCC minus ICRC, wherein IC is equal to IE over 2. So, therefore, this is our equation for the collector voltage. So, ganun lang. Nakita, ang ginawa lang talaga natin ay nag-loop lang tayo. So, kapit lang sa KVL. Example, so calculate the DC voltages of and currents in the circuit. So basically what we are being asked is kung ano yung in this case si VO1, wala. Okay, ayan. VO1, ano yung current dito, ano yung current dito. So yun yung mga pinapahanap sa atin. So first, gawin muna natin siya ng DC circuit, DC equivalent, and that is pag DC yan, i-ground natin to. So, dito rin sa kabilang side. Ayan. So, ito yung solution natin. First, let us try to find IE. So, to find IE, pwedeng mag-loop. Pwedeng mag-loop dito. Take note, this is our IE, also known as the tail current. Or pwede rin na, gamitin na lang natin yung na-derive na equation natin for IE earlier. So, we have IE is equal to VEE natin is 9 volts. So, wala na yung sign. Baka nagtataka kayo, sir, bakit hindi po negative 9 volts? Kasi, kinonsider na natin yung polarity ng VEE sa pagkuha pa lang nung equation natin earlier. So, you have 9 volts minus 0.7 volts over 3.3 kiloohms is equal to 2.52 milliamperes. That is our IE. With that, we can get the collector current which is half nitong IC natin, nitong IE natin. Or rather, nung tail current natin. resulting in a collector voltage of, since we already have IC, we can now solve for Vout1. Remember, ito ay nakalagay na VO1 saka VO2. Now, that is just similar with the collector voltage because that is, yun nga, the voltage at this point at the collector of your circuit. So, baka lang malito, o sir, ba't hindi VC yung nakalagay dyan? Okay lang yun. O, mag-loop tayo ulit dito, or gamitin na lang natin yung na-derive natin na equation earlier, and we will arrive at an answer of 4.09 volts. Yun lang. So, ganun lang yung pagsosolve natin. Yeah. Next, we will now discuss the AC operation naman of a differential amplifier circuit. So, ito na yung kasama. So, we still have the AC inputs. Now, itong AC inputs natin, again, reminder, the AC inputs are, yun yung ini-intend natin na ma-amplify. Diba? These are the AC signals na gusto nating ma-amplify. So, separate input signals are applied as V in 1 and V in 2 with separate outputs resulting in Vout1 and Vout2. So, to carry out the AC analysis, we redraw the circuit in the next slide. So, each transistor replaced by its AC equivalent. So, ito ngayon yung kakalabasan natin. O, very ano lang din to. Simple lang din naman siya. So, ito yung emitter, ito yung collector, ito yung base. So, ito lang din naman yung ginagamit natin dati, di ba? We have ang equivalent daw ng isang transistor kapag RE model yung ginagamit natin is this, a constant current source na merong resistance dito, Rin, which ang resistance natin, Rin na to, is actually equal to beta Re. So, this is beta 1 Re1. This is beta 2. No, not this one. This is beta 2 Re. Ano ba yan? Mali na naman. Re2. Ayan. So, ganun lang naman yung analysis natin. So, similar lang din. Tapos, ganun lang. Maglo-loop-loop lang din tayo. Tapos, gagamitin lang natin yung operations kumbaga, the theory or what we know about transistors, like the relationship of the currents, etc., etc. So, yun lang naman yung gagamitin natin dito. And kapag AC analysis tayo, di ba, ang lagi lang naman natin hinahanap is the gain. So, ito yung target natin. Laging makuha yung gain. Okay, now let us try muna to analyze single-ended AC voltage gain muna tayo. So, itong circuit na to, this is a single-ended AC voltage, AC differential amplifier. Bakit single-ended? Kasi we only have one input sa isang side. And then, grounded na yung kabilang input. So, to calculate the single-ended AC voltage gain, so apply, syempre, ito yung expected natin. Output mas malaki kasi may amplification na mangyayari. And then, apply signal to one input to the ground. Ito na yun. Now, ito yung AC equivalent natin, tapos single-ended. Ito yung V in 1, V in 2 is grounded. So, 0 volts yan kasi nakadirekta siya sa ground. So, the AC base current can be calculated using the base 1 input Kirchhoff voltage loop equation. So, to calculate IB, maglo-loop lang tayo dito. Going to the ground. No, not going to the ground. Going to, double check ko lang. Ayan, okay pala. Meron pa pala akong analysis na hindi pa nasasabi. Ayan nga. So, the AC equivalent, yung IB natin is makukuha natin using this loop. Siyempre, yung madadaanan natin yung IB. Now, the question is, saan ako dadaan? Dadaan ba ako dito sa RE? Or dadaan ako dito, papunta sa kabilang side ng equation natin? Kasi, ay, nung circuit natin. Kasi, di ba, remember class, these two transistors are identical. If they're identical, then their operation or their parameters are also similar. So, hindi tayo mahirapang hanapin kung ano yung IB1 tsaka IB2 kasi since identical yung transistors, alam natin na pareha sila ng value. So, therefore, if they are well-matched, we can say that IB1 is equal to IB2. And since same din sa transistor, their internal resistances are also the same. Meaning, R in 1 is also equal to R in 2. Now, with RE, very large, so ideally class, itong value ng RE natin is mas mataas, or ang gusto nga nating mangyari sa kanya, infinite siya. Para equal talaga yung makuha natin ng mga values on both sides of the circuit natin. So if that is the case, then we can assume that RE is infinite na lang kasi that's the ideal scenario. So if that is the case, class, ang loop natin ngayon is eto. Which is actually easier. Easier yung loop natin na yan because we know that RE1 and RE2, same lang sila ng value, and that is beta RE, as we have discussed in Electronics 1, kung ano nga ba ang AC equivalent circuit ng transistor. And then yung IB1 natin saka IB2, same lang din naman. So, even if hindi natin ito i-consider na infinite, ang best na daanan natin for the KVL is from this side papunta sa side na to. So, gawin natin ngayon yung loop na yon. So, yung loop natin ngayon, ito yung circuit kapag nire-draw. Kumbaga, ito yung dadaanan. Tinanggal lang natin yung ibang parts ng circuit. Pero syempre, kasali pa rin yun. Pero, ito lang yung loop natin. So, we have from V in, pupunta sa RE1, which is beta RE. Hindi natin papansin si RE. Palabas dito sa ground. Dadaan din tayo ng RE2, which is also R in lang din. So, ang ano natin na ngayon, ang circuit, not circuit, the equation natin ngayon is V in 1, positive, plus minus IB R1 minus RB R1. So, yun yung equation natin, equal to 0. So, this is our equation ngayon. Now, we know that IB, we can now extract IB, lagyan natin sa other side. So, we will have V in 1 over 2R in. And alam natin na yung V in naman equal lang din sa di ba? So, gawin na lang natin siyang V in since we only have one input. So, and we know that R in is equal to beta RE. So, substitute na natin. So, this is our formula for IB, or equation for IB rather. Now, if we also assume kung ang kanilang mga beta ay parehas, since parehas nga sila na transistor, then we can do this na lang. We can solve for, we can have an equation of IC. Kasi we know that that IB times beta is equal to IC. If that is the case, we will arrive an equation of IC that is equal to beta V in over 2 beta RE. Maka-cancel yung beta since ang assumption nga natin ay parehas sila ng transistor, identical sila. So, maka-cancel na to. And yung matitira na lang na equation natin for IC is V in over 2 RE. And the output voltage magnitude at either collector is, now, doon naman sa collector side, kung kukunin natin yung output, ito na rin yung formula natin kanina. Diba? V out is equal to ICRC. Nag-loop tayo. Hirap naman bumalik. So, nag-loop tayo on this side. We are now asked to get V out. Now, to get V out, maglo-loop na lang tayo from this point pababa dito. Now, in that case, yung magiging equation natin for V out is just equal to, V out is equal to IC RC. And na-solve natin yung IC kanina, di ba? And yung IC natin, that is equal to V in over 2RE. Now, pag pinalitan natin yan, we will have V out is equal to V in over 2RE RC. Now, meron na tayong equation na may V out at merong V in. So, therefore, we can now find the gain since alam natin that the gain is just V out over V in. So, i-arrange lang natin yung equation. We now know that V in over 2RE is equal to RC times RC is equal to V out. Then, ilipat na lang natin yung V in dito sa kabilang side para maging V out over V in. So, we will have V out over V in that is equal to RC over 2RE. And V out over E in, that is our gain. So, therefore, yung gain natin for a single-ended na operation ng differential amplifier is RC over 2RE. So, that is the formula for the gain. So, ito, example. Calculate the single-ended output voltage, V out 1, for the circuit. So, we are asked to get V out 1. So, take note, we have given sa atin yung R in, that is 20 kiloohms. beta ay 75. Now, ano yung good news dito? The good news is you no longer have to solve for RE kasi given na sa atin yung value ng RE. Kasi remember na ang RE natin is equal to beta RE. So, hindi na natin kailangan mag-DC analysis. Pero kung hindi given sa atin yung value ng RE, ang given sa atin is, o hindi siya given at all, we have to solve for RE muna. But in this case, hindi naman pinapahanap si RE o hindi natin kailangan hanapin kasi given na yung internal resistance nila. So, for the DC bias calculation muna, akala ko mag-given na yung RE. Ginamit ko rin ba? Ayan. Okay, class. So, in this case, ang solution ko palang ginawa dito, hinanap pa yung Rin. So, better din naman yun. Pero dapat, halos same lang siya ng kakalabasan. If we multiply beta to our Rin, ay 75 times kung ano yung makukuha natin na value ng Re, almost equal siya dapat dun sa Re na given dito. Okay, but anyway, let's start with the DC analysis. So, for the DC analysis, we need to find IE first. So, to find IE, maglo-loop lang tayo ulit. Ayan na. So, ina-emphasize ko talaga gusto kong ipakita lagi yung circuit kung saan naglo-loop. Kasi ayoko nga na maging kabisote tayo. So, sa DC analysis, ano muna to? Short circuit to. Dito tayo maglo-loop para mag-get yung IE natin. So, to get IE, that is 193 microamperes. Now, take note, ang isang kinakalituhan ng mga estudyante is that they consider IE, ini-equal nila sa IC agad-agad. Now, sa differential amplifiers, hindi ganun basta-basta kasi we need to look at the circuit. Ano ba yung tinutukoy natin na IE? So, yung iba, para hindi malito, instead of using IE to describe the current at this point, ang ginagawa nila, tinatawag nila to na IT or tail current. So, kayo yung bahala kung ano yung gusto nyong technique or naming convention na gusto nyong gamitin. But as long as susulat nyo talaga sa circuit at hindi kayo magkakabisote kung paano ba kinukuha yung mga equation, hindi naman kayo mag-worry doon. Kasi kung base kayo lagi sa circuit, lagi nyo makikita kung tama ba yung ginagawa nyo or hindi. Now, let us now find IC. Yung collector current na tinutukoy natin dito. So again, hindi ito yon. This is wrong for this example. To be exact, ang IE natin dito is, eto na, nakasulat na pala. IC is equal to IE over 2. That is IC. So therefore, we can now find our collector voltage, DC collector voltage, and that is equal to 4.5 volts. Now, yung loop natin doon is, nahirapan akong maglipat-lipat. But, yun nga, ang loop naman natin doon is, eto. So, from this point, palabas dito. So, yun naman yung loop natin. Yan. Now, since we have the value of our, IE, or IC, to be exact, hindi, sir, bakit po ang ginamit dito is 0.965? Bakit hindi ito? Kasi class, di ba, ang IE na tinutukoy natin dito is the current at the tail of the differential amplifier, not the individual currents, not the individual emitter current. So that is why ang ginamit natin to find RE is 0.965. And that is equal to 269.43 microamperes, which is just tama lang din. Ang given sa di ba? 20,000. So ang given kanina na RE is 20K. Now, may RE na tayo. Yung beta kanina ay 75. So, 75 times 269.43. This is equals sa, kinalkyo ko, 20.18K. So, kapag kinumpute natin using RE. So, hindi na rin malayo. Ayan. Pero kapag binigay ko na yung RE, huwag nyo akong gayahin. Kung binigay ko na yung RE, huwag nyo nang isolve yung DC parameters. So, diretsa na agad, gamitin nyo na yung RE. Kasi kaya lang naman tayo nag-DC para mahanap yung RE. Yung RE na gagamitin natin to solve for RE. Ay, actually, hindi rin pala. Kasi we need RE din pala to the game. So, kailangan din talaga natin i-solve. But, kumbaga, point is, consistent tayo with the answers. Kasi, we have this 20K and we have this 20.18K. So, halos parehas lang din sila ng value. So, kung gusto nyo, pabaliktad na lang yung pagsosolve. Kung given yung Rin, ang hanapin nyo na lang is Re. I-substitute nyo lang. Instead of finding Re, ay using the DC analysis, find Re by, kasi we know that Re, ano ba? That Re, yan, beta Re is equal to Rin. So, we can find Re, that is just Rin over beta. So, ganun din, makukuha pa rin natin yung Re. Ayan. So, pinakita ko lang, we have two ways to solve Re, given na given yung Rin. And that is using first one, DC analysis, kakagawa lang natin. And then the other one is using Rin. Kasi we know that beta Re is equal to Rin. Yeah, now we can get the AC voltage gain na since we have Re. And that is AV is equal to RC over 2RE. That is equal to 47 kiloohms over 2 times 269.43 ohms is equal to 87.36. And that is our gain. Ayun, so kung napansin, ano lang talaga tayo? Compute lang, circuit, KVL, loop. So, kailangan lang talaga familiar tayo dun sa kung alin yung parts na niloop natin, ano yung values na kinukuha, tama yung mga sign conventions natin, etc. etc. Now, ang tinahanap pala sa atin sa problem is the gain. Not the gain. I mean, V out yung hinahanap. To solve for V out, we know that AV is equal to V out over V in. So, AV. Yan. So, ang V out natin is just AV times V in. That is equal to 174.72 millivolts. Given na ang V in natin dun sa problem ay 2 millivolts. So, given naman na 2 millivolts yung input, so we can get the output. And yun nga, ang nakuha nating answer is 174.72 millivolts. Ayan. So, again, we have two ways to solve this problem. Kailangan makuha natin yung Re. To get Re, pwedeng mag-DC analysis tayo or gamitin natin yung given na Rin is 20 kiloohms. Kasi agad-agad makuha natin yung value ng Re dyan. Ayan. So, next naman is the double-ended AC voltage gain. So, in this case, class, halos parehas lang yung mangyayari. Kapag differential gain though, pinapangalanan na natin siya as AD. Kasi may sabihin, differential yung tinutukoy natin. And the differential gain class, that is equal to V out over VD. This is using the same, same na computation natin kanina. And that is equal to RC over RE. So, wala na lang yung 2 dito sa baba. Kasi pag nag-circuit analysis tayo, makakancel na siya, kumbaga. Wherein, yung VD natin is known as the differential input. So, VD natin, class, take note, that is known as the differential input. And yung differential input natin, that is V in 1 minus V in 2. So, this is our differential input. Now, this table now summarizes the voltage gains for the differential amplifier configurations. So, we can have multiple na dito, combination. So, pwede na ang input mo differential or single-ended. Tapos yung output mo naman, pwedeng differential and single-ended. Ito yung combination nila, kumbaga. Now, if ang input mo ay differential at ang output mo ay differential, yung gain mo is RC over RE. And yung V out mo, that is AV times the differential gain. Remember, this is also differential input pala, rather. This is VD. Now, kapag ka naman differential ang input, ang output mo ay single-ended, ang maiiba is your gain. Yung gain mo is RC over 2RE. And then, ang output mo is, ang V out mo is same nung sa kanina. So, that is AV tapos V in minus V in 2. Or VD times VD. Now, kapag single-ended naman, ang input natin at ang output natin ay differential, that is RC over RE. Tapos, since single-ended ang input mo, either lang dun sa V in or V into yung gagamitin mo. Now, take note, we have inverting inputs and non-inverting inputs dito. When we say inverting inputs in a differential amplifier, yun ay yung input kung saan same yung polarity niya paglabas ng circuit. Halimbawa, kukunin mo yung Vout mo, tapos kinuha mo siya on, tapos isang side lang yung may input. Depende kung saan side mo nilagay yung input mo, yung magiging sign or polarity ng output mo. In this case, our inverting input is V in 1. So kapag sa V in 1 mo siya nilagay, yung single input mo, tapos grounded na yung other side, your input will be in phase with your output. However, if nilagay mo siya sa other side, in your non-inverting input, that is in I2 or V in 2, ang tendency naman is magkaroon siya ng phase shift. Kaya negative AV, V in 2 yung V out natin kung sa V in 2 mo siya nilagay. Next, for single-ended input, tapos ang output mo single-ended din, then you will have RC over 2RE naman. And yung V out mo dyan is same lang din itong kabila. Since isa lang yung input mo, isa lang either V in 1 or V in 2 lang yung ma-amplify. So, ganun naman class yung nangyayari kapag parehas na single-ended yung circuit natin. Now, take note, meron tayong inverting input tsaka inverting output. Ayan, next, we have common mode and use of constant current source. So, common mode muna yung pag-usapan natin. So, whereas a differential amplifier provides large amplification of the different signal applied to the both inputs, it should also provide a small amplification of signal common to both inputs. So, ito yon. Assume natin, class, that this is your common mode signal. And yung common mode signal na to, sabihin natin noise yan. Siyempre, kung noise yan, papasok yan sa lahat ng pwedeng pasukan. So, papasok yan sa both inputs mo. Now, pag pumasok siya sa both inputs mo, same yung polarity niya na papasok dito, saka dito. As compared, kapag differential input, ang pinag-uusapan natin, opposite yung polarity nung pinapasok natin na signal. But this time around, ang ipapasok natin na signal ay parehas ng polarity. So, kung ganun yung case, class, ano ba yung mangyayari doon sa circuit natin? So, this is our analysis. Binalik lang natin yung AC equivalent circuit. But this time around, common yung signal. So, instead na naka-ground yung other side, di ba kapag single-ended, naka-ground dito. But this time around, hindi. Naka-direct siya na naka-connect dito sa VI natin. So, what we can do now is try natin ulit hanapin yung equation natin for IB. And to find that, dito wala tayong choice. Hindi tayo pwedeng umikot dito, tapos dito sa RE1, tapos RE ulit, tapos dito. No, hindi. Hindi tayo maka-form ng loop. Diba? Hindi tayo nakarating sa ground. Kasi tumama na tayo sa VI, wala pa tayo sa ground. So therefore, hindi natin, yan yung loop natin. Ang loop lang natin na pwedeng gawin is from dito, tapos R-in, pababa, papunta sa RE. So that is the loop that we will use. Now take note, take note kapag tandaan kumbaga, rather yung ating convention ng current or naming convention ng currents natin. So pag nag-loop tayo dito, we will have V in, tapos minus IB R-in, baba dito, tapos, plus current mo dito times RE. Now, take note, yung current mo dito is not just beta IB. Tama? Kasi, alam nyo na IB to, di ba? IB yung nagpo-flow dito. Tapos, ito, IE, ECA yung nagpo-flow dito. But again, hindi siya talaga RE. It is the tail current, the current that flows here. Yung IB natin, IE natin, is nandito siya. And that is yung beta plus 1 IB. Meron ding beta plus 1 IB dito. Magko-combine sila, yun yung tail current natin. And that is 2 beta plus 1 IB. So that is why, yung equation natin dito is ito yung kinalabasan. We have IB, pag nilipat na natin siya sa kabilang side, wala na to, V in is equal to 2 beta plus 1 RE over R in. And yung RE natin, alam natin that that is also equal to beta RE. But now, what we did is, nire-arrange natin siya. So, ang ginawa natin ay, wait, parang pati ako nalito. So, nire-write natin siya as IB is equal to, okay, tanggalin ko muna to I-rewrite ko muna yung equation natin, yung mismong KVL equation para hindi tayo malito. We have V in, ito, R in muna, minus IB, R in, minus 2 beta plus 1 R in. IB R in is equal to 0. Now, ang gawin natin is pagsamasamahin natin lahat ng IB, tapos ilagay natin siya sa isang side. So, ang magiging kakalabasan is IB, itong IB na to, magkakasama. So, we have R in minus 2 beta plus 1 R in. Nilagay natin sa kabilang side, so magiging positive. So, ito yon. Tapos, dinivide natin yung whole equation by that. And we will arrive at IB is equal to V in, R in plus 2 beta plus 1 RE. So, yun. Saan ko nakuha to? Bakit ganun? Okay, anyway, ayun. Basta, nag-arrive tayo dito at this equation. Now, we have our equation for IB. Next, for the output voltage, maglo-loop tayo ulit dito. And yung loop natin dyan is, we have V out is equal to ICRC. So, very clear naman dito sa loop na ginawa natin. Now, kung mag-loop tayo ngayon dyan, class, we know the value of IC is beta RB as beta IB. So, palitan na lang natin ng beta IB. And then, we have a value na rin for IB, which is this one. So, we will have a V out equation na beta V in RC over R in plus 2 beta plus 1 RE. Now, this would provide a voltage gain of, meron na tayong equation with both V out and V in. Lipat lang natin itong V in sa side na to para maging gain. Kasi gain is V out over V in. And we will have beta RC over R in plus 2 times beta plus 1 RE. Apply natin sa example. Tapos tingnan natin kung effect. Tingnan natin yung effect. Kung napansin, iba to, di ba? Beta RC tapos over RE. So, parang nagkakaroon na siguro tayo ng guess na mas malaki itong nasa baba kaysa sa nasa taas. Diba? So, kung mas malaki yung nasa baba kaysa sa nasa taas, ano yung gain, common mode gain na makukuha natin? That is mababa din. So, take note, AC yung nilagay natin na, na pagtawag. Kasi nga, common mode gain siya eh. So, calculate the common mode gain for the amplifier circuit daw. Hala, nasan yung circuit? I think. Ayan. So, wala pala yung circuit. Sige, pa-flash ko na lang yung circuit. Okay. Saglit. Please give me a few minutes. Ayan. So, habang hinahanap ko yung yung pangalan nito, yung circuit, reviewin muna, tingnan natin yung reviewin muna kung paano nga ba tayo nagsosolve. Kumbaga, i-gets nyo muna ulit. Balikan nyo muna yung mga parts na hindi masyadong na-gets. Ayan, napakagaling ko. Delete ko yung mismong picture. Okay, hanapin ko na lang kay ball stud. Differential Amplifier. Ayan. So, common mode, rejection. $10.17. So, okay. Nabigay ko na pala yung circuit. Okay. Sorry. Yung example pala na hinahanap dito is same nung kanina. So, we are going to use this circuit. 17. Ito. Ayan. So, this circuit. Clear ko lang ang ating mga... Ayan. So, this is the same circuit that we are going to use. So, kung yan yung circuit na gagamitin natin, ang kailangan lang naman natin is the value of RE, 43 kilohms. Value of RC, 47 kilohms. Tapos, we have to solve for RE, pero yung RE is na-solve na natin from this problem. So, pwedeng yun na rin yung gamitin natin dito sa problem na natin, trying to solve. So, if that's the case, remember that our common mode gain is equal to beta RC over Rin plus 2 beta plus 1 Re. And yung Re natin, that's beta times Re. Or pwedeng gamitin na natin direkta yung 20 kilohms na given kanina. So substitute that to the equation. We will have 75, that's your beta, times 47 kilohms over 20 kilohms. So this time around, ginamit natin yung given Rin, plus 2 times 76 times 43. So this is beta plus 1, tas itong 43 na to, that is your Re. Now, kung mapapansin, ang gain natin is 0.54. That means that yung output kakalabasan na signal because of the common inputs natin ay sobrang baba nung gain niya. So, mangangalahati siya. Kung meron mang signal na papasok doon sa ating circuit, sobrang baba na magiging value niya. So, that is the advantage of using differential amplifiers. Grabe. Walang circuit. Ayan. So, next, we have the use of constant current source naman. So, in differential amplifiers, di ba meron tayong tail current kanina? And ang ideal na ideal na resistance natin for the Re is actually infinite. Gusto natin mataas siya. So if that is the case, maybe we can use a circuit na magbibigay ng tail current pero mataas yung kanyang resistance. So by doing so kasi, mas mapapaliit pa natin yung common mode signals natin. So to do that, we can have this circuit. So we will now be using 3 BJT or 3 transistors. Pero itong pangatlong transistor natin is hindi siya nandyan for amplification. Nandyan lang siya to provide what? Constant current and high resistance. Napansin nyo, this is actually the circuit we discussed last time. This is a constant current circuit or constant current source circuit. So instead of just using Re, what we do there is maglagay talaga tayo ng constant current source. Now remember, ano ba ang resistance ng constant current sources? Diba? It is infinite. So kung infinite yan, then therefore, sobrang taas ng resistance at this point. And this is your whole circuit will be equivalent to your Re. Instead of using a single resistance, you use a circuit na ang resistance niya ay sobrang taas. So, ganun lang. So, this is the AC equivalent circuit for a differential amplifier with constant current source. Ayan, example, calculate the common mode gain for the differential amplifier. So, in this differential amplifier, kung napansin natin, tayo ay gumagamit na ng constant current source. Now, tingnan muna natin yung mga given. So, ito understood na natin to. Pero dito sa baba, meron tayong Q3, meron siyang beta, also equal naman dito. But we have RO. RO is 200 kilohms. When we say RO class, this is the equivalent resistance of the circuit, which we can see naman dito. Ang assumption natin class at AC analysis, the resistance at this point is equal to RO. So kung ganun yung case, then instead of using Re, ang gagamitin natin is RO, which is given dito as 200 kilohms. Kung napansin, yung mga Re natin kanina nag-range as 50 or 40 kilohms, diba? Now this time around, because we are using this circuit, ang equivalent na resistance at this point, wherein this whole circuit sees it as your Re in the previous na problem, it is now 200 kilohms. So, yun lang yung difference nito. Instead of using Re, we're going to use RO, which is 200 kilohms. Ito rin yung RO na sinosolve natin, yung output resistance ba. Ito rin yun, yung sinosolve natin dati kapag AC analysis. But this time around, given na siya. So, proceed lang tayo with the solution. So, instead of using Re na ginagamit natin dati, ang Re natin is the equivalent resistance of the circuit below, of the constant current source, which is 200 kilohms. So, therefore, applying it to the formula of the common mode gain, we will have beta RC over R in plus 2 beta plus 1 RE, wherein RE is RO. So we will have 24.7 times 10 to the negative 3 as our gain. So ibig sabihin, class, sobrang baba na nung gain nung common mode signals natin. So kung noise yan, ayaw mo yan na nasa circuit mo at pumasok siya on both your inputs, yung tatama sa Q1 tsaka tatama sa Q2, sobrang baba na lang nung effect niya pagdating dito sa output natin. Because sobrang baba nung gain niya. Yun. So that is the concept kumbaga ng common mode. Yan. So that is our discussion dun sa main discussion kumbaga natin when it comes to differential amplifiers. So yun lang naman kailangan nating matutunan. This is not extensively used anymore na, halimbawa, may differential amplifier, tapos gagamit ka pa ng mga transistors, hiwalay, ganyan. Hindi na, kasi sa loob na ito ng IC nangyayari. So, maganda lang na naintindihan natin kung paano siya nag-work. Ayan. So, ito naman, parang auxiliary lang to, auxiliary topics. We have BiFET, BiMOS, and CMOS differential amplifier circuits. So, whereas the preceding section provided an introduction to the differential amplifier using bipolar devices, so units commercially available also use JFET and mga MOSFET. So, an IC unit containing a differential amplifier using both bipolar and field effect, ang tawag natin doon is BiFET circuit. Ibig sabihin nun, may BJT ka na, may FET ka pa. Now, an IC unit naman na gumagamit ng BJT, tapos, ay, hindi pala. Mali. Ang ibig ko sabihin dito, class, hindi ka gumagamit ng BJT tapos FET. Ibig sabihin nito, ang operation mo, nag-ooperate ka using holes and electrons. Tapos FET yung gamit. So, ganun din dito. For BiMOS naman, bipolar siya, meaning nag-ooperate ka using both holes and ang carriers mo ay holes tsaka electrons. Tapos, MOSFET yung gamit mo. So, BiMOS circuits naman yung tawag natin doon. And the circuit using opposite type MOSFETs, ang tawag naman natin doon ay CMOS circuit. Di ba? Napag-aralan naman natin yan. CMOS, complementary metal oxide semiconductors. So, start muna tayo with CMOS. This is a CMOS differential circuit. So, the CMOS is a form of circuit popular in digital circuitry and uses both N-channel and P-channel enhancement type MOSFETs, MOSFET transistor. So this complementary MOSFET or CMOS circuit uses this opposite or complementary type transistors. So the input is applied to both gates with the output taken from the connected drain. So sa ating CMOS na circuit, nilalagay natin yung input doon, both doon sa gains natin. So take note, single input, kumbaga iisang input lang sa both gate natin pinapasok. And then, kinukuha natin yung output sa connected na drains nila. Now, remember kung paano muna nag-ooperate yung NMOS tsaka PMOS na circuit. Naku, ito pala hindi ko alam kung nasama to dun sa review. Pag NMOS tsaka PMOS, madali lang naman siya. At the point na, this is VGS versus ID. ID is the drain current, VGS is the gate to source voltage. So kapag NMOS, yung pinag-uusapan, pag naglalagay ka ng signal, or basta basically, pag naglalagay ka ng signal sa VGS mo, up to some point na ma-reach mo yung gate voltage mo, magkakaroon na tayo ng kuryente. So ganun din dito sa kabila. At the point na ang input mo, the more positive that your VGS becomes, the more current yung magpo-flow. Dito naman sa kabila, the more negative that your VGS become, nagkakaroon ka lalo, tumataas lalo yung current mo. Up to some point na ma-reach natin yung maximum current natin. Now, NMOS on and off operation. So, the drain characteristics of an N-channel enhancement type MOSFET. When we say enhancement type, you enhance the channel. Meaning, gumagawa ka ng channel. Kasi we have two types of MOSFET. We have depletion type saka enhancement type. When we say depletion type, meron ka ng channel, nagdi-deplete yan. So, the more you add ang kinokontrol mo is pinapalit mo yung channel. So, sa enhancement type, baliktad. Pinapalaki mo yung channel natin. Kaya nga enhancement, kasi ini-enhance mo siya. So, ibig sabihin, si N-channel enhancement type, this is normally open. Meaning, at the start of the circuit, hanggat wala kang nilalagay na input voltage sa VGS mo, hindi mag-work yung circuit mo or walang magpo-flow na kuryente. So that is shown in this figure. Nakita naman dito, di ba? Hanggat hindi mo nare-reach yung VTH mo, ay ano yung mangyayari? Hanggat hindi mo siya nare-reach, ang output current mo ay 0 volts. 0 volts, 0 amperes. So therefore, until such point, ma-reach mo yung VTH, magkakaroon ka na ng channel, at pag nagkaroon ka na ng channel, magkakaroon ka na ng surge of your carriers. So, ganun din kapag PMOS. So, with 0 applied to the gate source to the gate to source junction, there is no drain current 0. Not until VGS is raised past the device threshold level, VT or VTH. Now, with an input of, say, let's say 5 volts, the NMOS device is fully on and ID is present. So, if input of 0 volts, leave the NMOS off, whereas an input of 5 volts, it will turn the NMOS on. Now, ganun din kapag PMOS. But sa PMOS, iba lang yung polarity na ginagamit mo kasi ito yung PMOS natin. So, sa PMOS class, the more negative na binabias mo yung gate to source mo, more negative, dun pa lang tayo magkakaroon ng kuryente. Pag na-reach mo na yung VTH mo, ma-reach na natin yung point at which magkakaroon na tayo ng surge ng kuryente. So, ibig sabihin nun, class, at VGS is equal to 0, normally closed siya. So, therefore, naka-off yung PMOS mo. But at VGS is equal to, let's say, for example, negative 5, kung yun yung threshold voltage mo, magta-turn on yung PMOS natin. So, that is how the NMOS and PMOS operate. Now, let us now consider the actual CMOS circuit. Now, this time around, ay titingnan natin kung ano yung effect kapag meron na tayong input tsaka output. So, ang biasing natin dito, class, we have VDD. Ito siya sa taas. And then, this is our input voltages. Now, kung mapapansin, at input voltage mo is equal to 0 volts, at input voltage na equal sa 0 volts, ang output natin is positive 5 volts. That is because, at this point, at 0 volts, yung PMOS mo dito is naka-on. Or yung Q1 mo is naka-on dito. So, therefore, merong voltage na papasok dito. Or merong current na mag-flow dyan, magkakaroon ka ng voltage at your output. Now, on the other hand, kapag ka naman inon mo to, pag inon mo to, ito naman yung magko-close. Pag nag-close yung NMOS mo sa baba, so dito ka mag-loop, di ba? Kukuha ka ng voltage dyan. Close to. So, wala, ground na to. So, therefore, V-out mo is equal to 0. As compared to kanina, dito ka nag-loop, may VDD. So, meron kang output dito. So, ano lang to? Ito rin yung diniscuss natin last time sa CMOS na operation. Ayan, so ito rin yun. Tapos kapag input mo ay 5 volts, so review lang to class ha. So hindi na natin i-discuss. Kasi ito exactly yung diniscuss din natin last time. Ayan, next naman is BiFET. So, ang BiFET natin class, ayan. So, in this BiFET na circuit, we have, okay, so tama pala, when we say BiFET, we also use BJTs. Ayan. So, sorry for the confusion, no? So, this is our circuit for a BiFET circuit. Anyway, ano lang naman to, overview lang kung ano ba yung itsura ng ating circuit. So, this is just an overview or like, kung paano ba itsura ng mga BiFET circuit. Kasi in reality, sa mga ICs natin is sobrang complex kumbaga yung mga circuit natin. So ito kung mapapansin nyo, ano to? Current mirror to, di ba? Tapos ito yung dalawang FET natin, FET. So yon. So the current mirror ensures that each JFET is operated at the same bias current. So since yung current dito na magpo-flow ay equal sa current na magpo-flow dito, di ba na-discuss din natin yan sa current mirror, then therefore, the current flowing through the circuit will also the same. So, mamimaintain natin yung same operating parameters on both transistors. Now, ito naman, BIMOS na circuit naman to. O ito, mas pinasimple pa actually. Ginawa na lang constant current source dito, constant current source dito. But, syempre, meron tayong sarili-sariling circuit na mga constant current sources natin. So, the BIMOS unit, it provides even higher input impedance than the BiFET due to the use of MOSFET transistors. So, bakit ito ay higher impedance? Kasi di ba, ang hirap ipaliwanag ng, hindi ko alam yung background nyo with MOSFET. Kasi di ba ang mga MOSFET, insulated, tinatawag din ang mga MOSFET as IGFET or insulated gate field effect transistors. Kasi nga, insulated yung gate natin. Naka-insulate yung gate. Actually, yan, no? Kaya may space dyan. Kasi may insulation siya talaga. So, that insulation, it actually provides a very, very high na input impedance. So, that is why higher impedance din yung effect nitong BIMOS natin. Now, ito CMOS as a differential amplifier. So, paano ba siya nagagamit yung CMOS natin as a differential amplifier? So, overview lang din naman to. So, ito yung itsura niya. So, finally, a differential amplifier circuit can also be built using CMOS transistors. Ito yung itsura ng circuit. So, the PMOS transistors provides the opposite inputs. Ito yung input mo. Ito yung kabila. Ito yung inverting, ito yung non-inverting input. Ito naman yung inverting input natin. Whereas, the NMOS naman dito, it provides your constant current source. So, ito namang nasa baba na to, it provides your constant current source. Nakita, ito yung may, na-discuss din natin to, di ba? Pero BJT yung gamit. A constant current source na merong Zener diode. So, a single output is taken from the common point between the MOS and the PMOS. So, kinukuha natin yung output class in a common point dito sa dalawang to. So, this is where we take our output. This type of CMOS differential amplifier is particularly well suited for battery operation due to low power dissipation of a CMOS circuit. So, remember, ang CMOS class, hindi mo kailangan ng sobrang taas na power para mag-switch yung kanyang mga from one operation to another. Kaya nga, mas ideal to na gamitin. Mas mabilis din ang switching speed nito kaysa sa BJT. So, very ideal siyang gamitin for mga integrated circuits or for battery operations. Yan. So, that is it for our discussion with this chapter. So, itong mga to, hindi nyo na to makikita sa mga specification sheets, etc. etc. Kasi this is a form na of circuit. Tapos itong form na to ng circuit, hindi na siya masyadong ginagamit. Since sa IC circuits nga, yun na yung inaan natin, mas pinaprioritize. But anyway, maganda pa rin na alam natin kung paano ba siya ginagamit and kung paano pa tayo nagsosolve din ng mga different parameters kapag given yung mga differential amplifier natin. Now, this is actually the last circuit na pag-uusapan natin na mga BJT pa yung makikita nyo. In the next chapters, op-amps na yung mga didiscuss natin. Now, before we proceed with op-amps, etc., or kayo, before you opt to proceed with op-amps, with a different topic, make sure na na-master nyo na kung paano mag-solve ng mga gantong klaseng circuit. So, yung pagluloop, paghahanap ng input impedance, paghahanap ng output impedance, pagtitevenize ng circuit, pagki-KVL, paghahanap ng sign. Ano ba yung sign? Pati yung mga single and double notation. Like, let's say, for example, maglagay ako dito ng let's say, reference voltage VA. How do you get VA? Diba? So, to get VA, you can have multiple things. Pwede mag-loop ka na lang dito. Ayan. So, dapat ma-master natin yun. Papaano rin kung naglagay ako dito ng isa pa. Let's say, naglagay ako ng another node. Nilagay ko dyan ay, let's say, VX. So, paano ko kukunin yung VX? So, pwede mag-loop ako dito. Now, paano pag sinabi ko na, hanapin nyo si VAX. So, paano nyo siya kukunin? Diba? That is just VA minus VX. So, yung mga ganito ba? So, hindi ko kasi alam to what extent nyo siya na-discuss nung electronics 1. But the point is, before we move on with the next topic, familiarize na natin yung self natin dito kasi hindi na tayo masyadong mababalik sa ganitong klase ng computation. So, nakakalungkot naman, Or sayang naman kung, yun nga, wala na kasing opportunity na balikan tong mga ganitong topic kasi nga, mag-move on na tayo to another chapter. So, yun lang. And that is it. So, you may start na with the exercises in this chapter.